So, remember about the assembly line? That assembly line is coming and Mahesh is picking up each of the object, so that each object here is a horse and you are doing it. Remember that first class? Where did I execute that horse race program? In one machine, correct? So we executed the code and we have run it on one machine. So as you can see here, how should I minimize it? Yeah, there is only one node and there is only one data set. Now, assume that you became a Scala programmer. The moment you come about Scala, you will think about parallelism. Scala is a very good programming language, functional programming language for parallelism. And the moment I am converting my Java program into a Scala program and I am going to run on the same computer, the only difference is I am going to have many threads. Each thread will be running the host. That is the example that I have shown you in Java. So assume that equivalent program I am writing in Scala. So Scala will have the multi-threads and it is there. Now the most important thing here, you have split the data. Your data is divided into many horses. Each horse is running on a thread. Workers or threads independently operate on the data which is parallelly divided. What does that mean? If suppose I have got 12 horses, if I have got 4 threads, 3 horses each will be on each thread, right? They are all working independently. And finally, out of the 4 threads, somebody is going to gather the result and tell that first price is this, second price is this, third price is this. Again, one system. So what was the first program? One system, one thread. All the 12 horses in one thread. What is the second example? One system, 4 threads. So 3 horses each. What is the next? Guess, what is the next?
Many systems.
Many computers now. So one is mine, one is Krishna's, one is Mahesh, one is Vivek. There are 4 computers now. Where is the data? How is the data shared? There are many nodes and there are many data sets now. Now all the concepts that you studied will come into picture. What? Hadoop, MapReduce, shuffle and sort, mapping, and then writing the result. Reducer is taking the result, correct? We have many data sets. So rather than telling share, call it as distributed. And this is how the distributed programming came in. And what will happen in the distributed programming? In distributed programming, you have to split the data over several nodes, right? Node is nothing but a computer. So we have to split it. Next, nodes independently operate on the data shards in parallel. So there is no worker or thread. Worker or thread was only on one machine. Now each node is going to work on independently on that data. That is the concept of map and reduce, right? Whenever you are doing the map, remember twinkle one, little one, each one of you was writing it individually, right? It is working independently on data shard. Remember that word, data shard. What is meant by data shard? The part of the data that you have, shard. The total 12 horses, 4 horses each. That's the data that you have. And somebody needs to combine when necessary. Who combined in MapReduce? Reducer. Got it? Okay. Very interesting slide. Let me just make it a little bit big. Anybody know what is meant by L1, L2 and L3?
Latency.
Not cricket. L1, L2, L3. What is meant by L1, L2 and L3? Okay. Before going to L1 and L2 and L3, what is 286, 386, 486? Have you heard about these numbers anytime? Whole life? No? Okay, I will write one more. Then you will tell me, oh, I know it. Have you heard about this?
286 processors.
Oh, these are all processors. When I started, it was 286, 1 GB hard disk. India, it was 25,000 rupees. 286, 386, 486, Pentium. After Pentium, what happened? Call it as 586. Is there a 686? 786? No, it stopped here. Why? What Shashi is smiling?
No, I'm trying to recollect.
I told you all this in between the discussions.
Space issue.
What is Moore's law?
Yeah, it's proportionate to the size.
Every year, processing power doubles and the size halves. Processing power doubles
Size
and the
reduces by
size
half.
is reduced by half. That is why the computer, which was as large as this room, now has become inside your phone. It is Moore's law. It started from early 50s onwards. The day processors were invented, on those days onwards, every year we are seeing drastic progression in the speed. Earlier computers maybe 500 instructions or 500 or 50,000 instructions per second. Today you are getting 2.69 gigahertz, which is unimaginable to that number. Why? Doubled. But you know what happened when everything started doubling
Saturation.
and size halved? Okay? I told you this, right?
Yeah, you
Yeah,
told
you
us
said.
it was.
So read that Intel Tejas. Remember? That's what I mentioned to you earlier. Tejas failed. Why? They were trying to create the next processor. And when they created and started running that, they found out that the heat and the energy is creating big problem and it is not becoming, usable. So they stopped and Tejas was taken aback, telling that this processor cannot go to the world. So tell me then, what is the next idea they might have thought? Instead of creating one processor like this was like this, right? Your CPU looked something like this, right? This was what? What they did? What is this called? Cores. You ask a question, right? Informatica, how many cores? Huh?
64.
License, money.
64.
Company pays by cores. So your CPU is cores. How many? Bibin's
8
machine.
cores, 8 cores.
Not 8. I don't think.
16?
So about this Mac and software. Oh, sorry. About this Mac, I think it is a system report. L2 cache, L3 cache, total number of cores equal to 4. What happened to programs then? What will happen to multi-threading? In this, when I wrote the horse race example, the multi-threading program, 12 horses are running, 12 threads are running. Here? How? Your program is not designed to divide the threads into each core. Where did you write the code? You wrote the code for assuming that it is one processor and one core. You need a programming methodology where you need a mechanism to utilize how many cores are needed. If I write local 1, I should use only one core. If I write local star, use all the cores. Understanding? A programming methodology has to be changed to satisfy cores. Java has a method, get available processors, but that's not giving you the exact way to divide your work into cores. And then, next important idea came into picture. How will a normal processing work? This is your hard disk. Assume that you put the data, twinkle, twinkle, little star, and you want to do MapReduce. Can you tell me what will happen? That twinkle, twinkle, little star is on the disk. First, it will be taken by the CPU and will be put it into what you call as the RAM. And then you are going to process it. And then you are going to write the data, intermediate output, where the intermediate output of each twinkle one will go in the normal file system. And from the normal file system, the reducers are going to take it by shuffle and sort. And then it is going to calculate the result. How many times the CPU is going through the RAM, disk, RAM, disk, RAM, disk? Understand? They told that, okay, RAM is like, there is an almara there, okay? Whenever I want to take a book, I go to that almara and take a book. But most frequently used books I can put on the desk now. So that I don't have to go to that almara. I am the CPU. And not very less frequently used books, but after most recently books, let's say some 5 or 6 books, I use it after this set of books. So I'm going to keep it inside the rack. The second preference. Third preference, almara. Now you tell me I want to take a book which is very, very frequently used. From where I'll take it? From the table. That is called L1 cache. Inside this L2 almara, the normal RAM or L3. Now look at this picture. L1 cache, very fast, nanoseconds. L2, little, 7 nanoseconds. Main memory reference, almara, 100 nanoseconds. Look at this terrible one. If you want to read the data from the disk. So what is the difference between memory and the disk? About 10 to the power of 5-6 times. Correct? What did MapReduce do? Where was the data? HDFS, which is disk. Where did the MapReduce write the output? Disk. Where the shuffle and sort happened? Disk. From where the reducer took the data? Disk. And finally, where the output was written? Disk. What you understand? There is a place for improvement. This young, smart professor, Mate Saharia, solved it. Okay, so this is 10 to the power of 5 times faster. So now you can just go through this. So if you look at the way in which memory, disk and network is happening, it is like memory is seconds or days, disk is weeks or this one months, and this is weeks or years, right? MapReduce was groundbreaking. It provided a simple API for writing the map and reduce. It created fault tolerance, Hadoop ecosystem to scale thousands of nodes. How did you scale? Yarn. I mentioned to you all the things. Hadoop 1 used job tracker, failed, and then we went for Yarn, resource manager, node manager, etc. Right? Shuffling happens between the network. Intermediate files are written into disk. Both you have seen in the graph that takes lots of time. Right? So can you guess how can I remove that disk seek time and the network latency? Any idea? after you heard this much? And first of all, MapReduce was very successful, and MapReduce created all the output, whatever we wanted, we can visualize into R, we have seen everything, right? What is the fundamental problem of MapReduce? Is there any problem at all for MapReduce? Okay. I want to write 5 reducers after a map. Can you do that? You never asked this question. Map, reducer, then another reducer, another reducer, another reducer I want to write. Is it possible? Answer is no. Can I write 5 maps followed by a reducer? No. The only thing that you can do in MapReduce programming model is you must have a map. Shuffle and sort is by the system, and then you have a reducer. Map, shuffle and sort, reducer. Map, shuffle and sort, reducer. If I want another reducer, I have to write a map and then a reducer. And what is the problem with this approach? Let's assume that your data quality team is wanting to do analysis of 5 data sources coming from Oracle, SQL Server, blah, 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 some 5 servers, okay? You have created a MapReduce program and you created your output. This is your output coming from 5 data sources, okay? Let's say these are the 5 data sources and this is your actual output that you created. Now you are creating a reducer, okay? So you created a reducer and you are counting a number of nulls, for example, for your data quality. And you did it successfully, you got the result. Now somebody else is coming. Shashi is coming and telling that you did all these things, but I want some other reducer from this data, give me that. What is the only option that you have? You have to write again. I can't reuse that. And in analytics, in machine learning, in the normal enterprises, what is required? Reusability. Reusability at each stage. Because after this map, one will be running a decision tree algorithm, one will be running a Bayesian network algorithm, one will be running a naive Bayes algorithm, one will be running a tree or decision table algorithm, right? I want that data to be available, but I don't have any choice in MapReduce to do that. So, Spark came in. And Spark introduced a beautiful concept, and they call it as RDDs. What is RDD? Resilient Distributed Data Set. The first thing that I did is what is meant by resilient in the dictionary. Resilient, just think like rubber band, one which can regain the shape. Resilient, distributed data set. That's what RDD is. We'll see what it is in detail. Okay. Again, going back to the old graph, weeks and years, run your program, use disk, use network. That was solved by your MapReduce and Hadoop. What is the first part where you want millisecond response and we want fast analytics? Spark is addressing that particular part. So that is a history. 2009, Spark was created by Mete Saharia at UC Berkeley. Spark became an open source in 2010, dedicated to Apache in 2013. Current version of Spark is 2.4.0. Very fast. When did Hadoop release? 2008. Just see, we never came to know that such a project is going on. They were parallelly creating that in 2009 itself. So maybe some other technology is already going on. It will come. Next course. God is very kind, so that he will update the technology every year. I can also teach. Right?
Use Spark and Scala.
Yeah.
Yeah.
A lot. not the proper way. I will tell you later what
Was
we'll
he a
use.
student, the guy in 2009? At the university, was he a student? The metal.
No, he was an
Okay.
assistant. Yeah, he was an assistant PhD thesis. It is his PhD thesis. So, AMP lab in Berkeley created it. I mentioned to you in the last class the full form of AMP: algorithms, machines, and people. It was created in 2011, 6 year, 65 students, postdoc, faculty, and staff. Funding is from Google, DOE, DARPA, everywhere, and they created BIDAS. What is BIDAS? Then I remember 2, 3 batches before one funny guy was some kind of ass he told. Ber- Ber- Berkeley Data Analytics. Okay, and Google, please do search this. Okay, and type Berkeley B dash and then press enter and then eh, no, we have Berkeley. What is the spelling? B.
It's right there.
Showing
Showing
totals.
Yeah, that's what you want. MP lab, algorithms, machines, and people, and look at the graph. And just have a peek at this graph sometimes. These are all the technologies that came in. And look at this bottom part, okay? Don't look here. What is this? Apache Mesos. Recollect everything I told you. You should be very deeply, you will be able to go through. Why? Because your concept is very solid. That's why we went through all that cycle of Hadoop 1, Hadoop 2. Why I taught you all these things? I could have skipped that Hadoop 1 and Hadoop 2 completely and directly went to Hive. What is Mesos? What was the problem of Hadoop 1? Job tracker, task tracker, what was the problem? Job tracker was not able to handle everything. So they divided the responsibility of the job tracker and they created what?
Yeah.
Yarn. Correct? When did Apache Spark started? Just now I told you, 2009. Was Yarn there at 2009? No. Then what Sahari and team did? They understood that there is a need for somebody to divide the responsibility of job tracker, that particular framework is needed in order to efficiently do the programming. And since they don't have Hadoop and Yarn at that time, they created their own resource manager, and that is called Mesos. So the first versions of Hadoop Spark came on the top of Mesos, and slowly Yarn released. What did they do? They told that okay, Spark can run either on Mesos or on Yarn. So in your company and all, whenever you run, you will type a command. What does that mean? You are running the Spark cluster on Yarn. And remember what was Yarn? Yarn was an operating system. It allowed you to write different kinds of applications. Spark is one kind of application on the top of Yarn. Are you with me? Right? So, coming back here, that is what BIDAS is all about, right? And now you will ask, hey, I'm studying so many things, which one I should use? Okay. Wherever there is a red color, that means it is a winner, almost a winner. Okay. Don't say that the other one is bad or other one is gone out, but prominence is for the red color. White means nothing. 2 red means almost equal. Relational NoSQL databases, almost both are very important. HBase versus Cassandra. Cassandra is gaining importance. Cassandra is a columnar database like HBase. Can you tell me another example of a columnar database? Sailfish. That's the one which we are using. Sailfish is the new name of Netezza. Now, Redis Memcached versus React. React is almost gone. These two are memory-based databases. MongoDB, of course, number one. Neo4j is a graph database. Solar versus Elasticsearch, both are very good. MapReduce versus Spark, this is going down. Spark is gaining importance. Spark Streaming and Storm, no clear winner. Spark SQL, Impala, Hive. I don't like all the three. Presto. Mahout versus MLlib versus H2O, MLlib.
You colored it?
Yeah.
Then why did you have Presto?
I didn't write that at the time when I created this slide, I didn't write it. So, the old big data was like this. What does this mean? So, Vasavi is here, huh? And Shashi is here. Where are you? Oh, you are here, Krishna. Enjoying the beach, right? So, Krishna is Hadoop. So, she wants to run Hive. Hive is with Vasavi, so she has to come to this building. And immediately HBase, so Shashi is far away, St. John's. Different buildings. Why? Like this. Hadoop MapReduce came, and then so many technologies came telling that, okay, if you want fast access to Hive data, use Impala. If you want streaming, use Storm. If you want to unify the data, use Drill. If you want machine learning, like Mahout. Different buildings and different islands. If you learn Spark, you don't need to do any of this. Why? Because Spark has got everything combined into one unified engine, which is one house. So you don't have to go to different buildings. In one house itself, everything is available. That's the whole concept of Spark. So the definition of Spark is a unified compute engine. Right? Now, this is the copy of that graph. So you may ask a question that whether I should replace or whether I should reuse. MapReduce? Yes, I should. A solid arrow means that a replacement. A double-ended arrow means either or. What is this? Yarn. What is this? Mesos. You can use both. HDFS or Tachyon. Tachyon is the new name of something called Alluxio. Don't worry about that. Hive? No, I will use Spark SQL. Mahout? No, I will use Spark machine learning libraries. Storm? No, I will use Spark Streaming. Spark everywhere. So one engine, you can do everything. What is the advantage of Sailfish? Sailfish has got an internal Spark inbuilt. So you don't need to worry about Hortonworks and all the other platforms. In Sailfish itself, IBM is shipping you the Spark code. So if you want to write Spark on Sailfish data, you can do it. That's the advantage. Okay. Anyway, this is all Apache web pages. So you can look at this. Do you know the site where you will be looking at the status of any open source? Please go to, this is a very useful site, openhub.net. See, design, track, and compare open source, and type there Apache Spark and press enter. Look at that, Apache Spark, and then you click on this. You will get all the details. I'm just showing you the, see, the project summary, how many people are writing it, and what are the similar technologies, and if you come down, what is the license, and how many vulnerabilities are there, what is the security, and how much code is there. How many lines of code, and if you look at in which language it is written. So that answers the question, right? I told you, because of the functional programming language features, Scala is selected as the default language for Spark. You can see that this deck I have already shared to you, right? Just skip some of the things, and because we are going to write some code, right? There is some experiments going on. One of such tool is called BlinkDB. I'll just tell you what does it. Assume that the CEO wants to go for a meeting, and CEO is asking you, hey, roughly what is the total claims amount that I received yesterday? Roughly, what is it? Because he's going for a meeting. He does not want somebody to count exact amount and tell that, right? 10 million, 20 million. BlinkDB, you can ask a question telling that, give me approximately, and it will find out. It won't give you the exact answer, but it has got the ability to find out with what percentage of error you want the result. Very fantastic and very innovative project. How it will do? What it will do is that your entire data is there. This is the true answer. Look at this. This is the true answer, the correct answer. It will create slices. This is 70% correct. This is 60% correct. This is 50% correct. And when the CEO is asking, hey, 50% roughly, what is the total claim? He will just immediately give you an answer.
Can it run on multiple databases? Or just
Of
one?
course.
It does.
Yeah, it does. It is for rough estimations and all, right? It is mainly.
Complicated queries too.
Pardon?
Complicated queries too, or just simple ones? Simple summing up averages.
It is not a simple summing up average. There is a way of querying BlinkDB. You will tell select star from this particular table with confidence or with error. Then it will calculate it because it is internally sliced it and it is picking up a value from that.
And it will show you the query on the side.
Yeah, it will show you the query. Correct. Okay, so what is the Spark architecture? Spark will work on HDFS as well as local file system. It has got data nodes, it has got worker nodes, and all the worker nodes are going to work on a piece of data just like how you have seen the different blocks in Hadoop, and then you are going to get the result. So what did you achieve other than Hadoop? What is the difference between this and Hadoop MapReduce? It's exactly same, no? What is the difference? Why I told you this one? This is what you have seen, right? And Mahesh, Krishna, everybody is going to take the data and write it twinkle, comma, one, and then finally there is a reducer going to happen, and then the result is going to come, right? Where is the difference? Please look at that. Everything is in memory. The entire data set is in memory, and the shuffling, the calculations, the narrow and wide transformations, everything happens in the memory.
So will it take data on the fly from disk in order to calculate all these things in cache?
No, it will take the data. I will tell you how it is going to work. Okay. Then you are going to the old traditional model, correct?
Yeah.
What is the difference? I understand your question. I'll tell you how it is going to work. Okay. That's a small bit of code. We are going to experiment this.
And Ravi, what is the major? So what is the major difference between Python and Scala?
First thing that you need to know is you can write either Scala or Python or Java in Spark. So Python programmers very happy. I don't do Python, but I normally concentrate on Scala. The reason is Python is a very good language, but it is not a strongly typed language. Scala, Java, etc. are very strongly typed, and since I am coming from the C++ Java background, I feel confident in writing Scala instead of Python. But you can use Python as well. Lot of machine learning libraries are available in Python. So you can put your Python code as it is inside Spark. Okay, let's understand what each thing means. In Spark, everything is implemented using the concept of RDD, already we mentioned, resilient distributed dataset. Now let's understand what it is. Take our word count line, okay, and we are going to execute it. instead of MapReduce using Spark. So let's say twinkle, twinkle, little star, and then let's say twinkle, 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 twinkle. 2 lines, just for. I will use always a constant in my Spark program, and that constant is called SC. SC stands for Spark context. Without Spark context, you cannot write a Spark program. Can you guess what is this Spark context will give you? The environment, right? All the way, or where all the computers and everything, where and all it is deployed, all those information will be given by SC. Are you familiar with the servlet programming at any case? Anyway, have you ever written a servlet? Servlet config, servlet context, similarly Spark context. SC. Okay. And then you are going to write a method. Normally, the method for testing is called parallelize. So just remember this, sc.parallelize. What sc.parallelize will do? This is the beauty. What did Hadoop fs minus put did? First, please recollect, the name node will take what is the data. Name node will divide the data into 128 MB blocks. Then it will put it into available blocks. It will create 3 copies. It will also store the information about where the copy is, correct? Name node, will it contain any data? No, not at all. Only data nodes will contain the data. And where is the data? On the disk, right? HDFS. Exactly the same thing. Spark is going to take the data. Spark is going to divide this into RDDs and going to store that RDDs in the memory, not on the disk. Are you getting the difference? Now, will it execute the moment you write the code sc.parallelize of this data? No, it will not execute. Then you will ask me, what will happen sc.parallelize if I give this data here? What will happen? What will happen is very intelligent. What Spark will do, Spark will think, okay, this guy wants to read this 2 particular data. I know how to read it, but I won't read it now. It will create a plan. Are you following me? It won't read. But when you write Hadoop fs minus put, it is done. Done deal, correct? It is already written. The moment you write this sc.parallelize, it will create a plan.
Using what algorithm?
Just a plan of how to pull the data and how to create the RDD. How much I should pull? 128 MB. It will use the Hadoop based configuration. So 128 MB, this line, Mahesh is going to create a plan. You didn't execute it. Sarita will create a plan, this line. All the other nodes also will create the plan, because plan means no space. And can you guess why all the nodes are creating the plan for that? What is the need? Only 2 lines, no? Mahesh and Sarita. If this node fails, then the other nodes know how to create the plan. What did you do in Hadoop? You created 3 copies. What did Spark do? Rather than creating 3 copies, it told you how to do it, but didn't tell you how to do it. See the efficiency there, right? Only when it is needed it will do. Are you clear so far?
So what is the importance of this plan? I'm still trying to
Wait. Now I want to count. This line that you are writing, lot of lines like this, are called Spark transformations. The final thing that you want to do with the data, like count, like print, etc., they are called actions. So, please listen. SC dot parallelize this data. And then I am writing that, okay, reverse all the lines inside, all the words inside this particular one I am writing. Okay? And then I am going to write that, okay, after reversing it, attach a word called hello to each and every word. So SC dot append, I will write hello. I am writing some code. What are all these transformations? And whenever you are writing transformations, what is Mahesh doing? Plan, plan, plan. Nothing is done yet. See the magic there. It is creating a lineage graph. That is the official word. A lineage graph from the start until that point. Finally, somebody will come. What is the need of all these things? SC dot print or SC dot count. What is that? It is an action. The moment that action is coming, you will start. You will start doing it. At any point in time, if he is failing, since all the other nodes knows the plan, it will just transfer that. Okay, please execute. Getting it? Wait. Now, there is a line, SC dot print only one. What does that mean? Only print the first line, let us say. See the efficiency of Spark. If your file is containing 20 million lines, rather than loading all the 20 million into Hadoop, it knows that the final is only one. So from beginning onwards, it will take only one line.
So will the plan stores the code or the instructions?
Everything together. The code plus little bit of what to do, how to do. In SQL and all, it is called a query plan. In Oracle and all, you can just check the query plan, explain. It will tell you the plan of how it is created. You understand? So, remember in Spark, everything is an RDD. Second, Spark is a set of transformations and actions. Okay? And the third, don't write, it is all there in this material, I will give you. Third, whenever there are transformations happening, the nodes will not actually do anything. It will create only the plan. And the moment action comes, it will execute it. Right? Now, coming back to the old question. Krishna is doing data quality on large amount of the data. She created an RDD. SC dot parallelize that big data that she got. And I stored it in RDD called input RDD is my variable name. I stored it in an RDD. Okay? RDD is a resilient distributed data set. I created it. Now, this RDD, I don't want anybody to recreate. Remember that was our problem? I will just write one line, input RDD dot cache or dot persist. There are two methods. The moment I write this as in cache, your input RDD, that entire data is residing in the memory, and now Sarita can use that input RDD. Shashi can use that input RDD without loading the data again. That means any number of reducers you can write here. Any number of mappers you can write here. Any number of actions you can write here, which completely eliminates the drawbacks of Hadoop.
So inputted RDD storing in cache?
Yes, cache is memory.
Cache memory, yeah.
Yes. So in the memory, your entire data is staying.
So what is the size of this one?
Very good. It is a huge question. So Spark, the memory is used for data as well as computation. You should have enough big cluster to have that data. For us and all, that is not a problem. 50 machines with about 64 GB RAM, I think. So it is about 3 terabytes. Out of that, you reserve 1 terabyte for your data, 2 terabyte for your computation. Is that clear? So what we can do? Please open the virtual machine. and open a terminal. Oh.
Both of them doesn't tell her that. She has it, but she doesn't have VM.
See, learning Spark by theory.
Some issues, it's not powering on.
New movies released now. 4 or 5 movies came, I heard. You both should get a new laptop.
Hmm?
Yeah, your laptop fell down, right?
Lot of applications, sir. But proud.
If you see any good deals, let me know.
I think FB has got the deal, no?
That's the one. That's
That's the only one.
What is it?
Otherwise, get a student. Yeah, she's there now.
Hmm.
Student license, you will get additional.
$50.
What is that?
$50,
Deal?
that's it. 10% or 15%?
Students will have
No,
some
not
No. The one which you are
10%.
telling in
10% or 15% is there.
Okay.
Employee.
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 Employee discount.
Yeah.
Mac, you will not have offers.
Huh?
Mac, you won't get offers.
Because of the quality.
You used employee discount. No? No
I
discount?
went to some other site. I don't remember what other site. From there I got.
Do we have to install something for Spark?
Yeah, we installed last class in local. Nothing for Spark.
No, Spark, this is the one. It is having Scala inside. Otherwise, how will you write the Scala code? I'll show you how to do. Okay. Look at this. You got the virtual machine running. Open the prompt. Type Spark shell. Press enter. So you will see, as I mentioned to you, the older version of Spark, it is 1.6.0, and finally you will see 2 very important lines, and you have to note those lines. Spark context is available as, what does that mean? In any of your code, you can use the variable sc dot, and SQL context is available as SQL context, SQL context. So these 2 variables are by default given to you for writing your Spark code. Just practice RDD on this for this particular course now. Okay, you can go to advanced programs and all later. Master RDD in the coming weeks and coming days. You are not there. So in the beginning I was telling that just concentrate on the RDD for now. Don't much concentrate on Spark code until and unless you get a good handle of Scala. Right? So Scala prompt has come, and I mentioned to you to copy that line and paste this one. Value words RDD equal to sc dot parallelize. Right click, copy, go here, and then open the command prompt.
So what is the PPT name, Ravi?
in Spark Notes.
Spark Notes.
Ah, oh, sorry, I didn't tell you. Go to forwardsun.com/passion/Spark Notes. What is the window? Okay. See, when I copied it, the double quote is not getting copied correctly.
Okay, Spark Notes and
Day 1, go inside day 1
one.
and you will see there are two materials.
Session 2.
Yeah. Look at that. When you write that line, it is telling that it is going to create this particular RDD. Remember, it is going to create. It didn't create. It's a plan. And now you want an action. An example for an action is count. So, what is RDD name? Words RDD is the name, and type count. You executed an action. When you execute that action, this also will get executed. Until and unless you execute an action, nothing is going to happen on the Spark cluster.
Three words.
Python, Scala, and Java. Did you type? Anybody? You have to be very familiar with the concept sc.parallelize, then create a list and then write Python, Scala, and Java. Type sc dot and then tab. You will see all the functions that are available on sc. Sc dot tab. Tab key. Next line, right?
Yeah, I got it.
Oh, sorry. Control L for clearing the screen. You started? You started? No. You got it, Sada? Vasvi? Spark Vasvi, like Spark you have to do. Okay? Go to the next slide.
Next slide.
You got it or not? Mahesh?
I'm still trying to figure out the PowerPoint. I think, yeah. Yeah, got it.
What should I do? Spark Notes, day 1.
Yes, inside that.
Spark intro 1.pdf. Not there?
It's there.
Ah, that's it. Next, the log aggregation program. Look at this way. Val lines equal to sc.text file. Next important method is sc.text file. What text file will do? It will read a file. Earlier, what did we do? sc.parallelize. Parallelize, you will be hard coding the values. sc.text file means it will read a text file. And then what does this is what is this doing? Last class. What is that doing? Second line. It is very easy, no? Lines dot filter. What to filter? Take every line and check whether that line is containing the word Scala. And it is going to give you an RDD again. So this is an RDD. You created another RDD. What are you doing? You are doing an ETL. You created one object or one file, and from that you created another file, right? And then you are telling that, give me the first of it. And tell me how to count it. These are two actions. When you write two actions, these two RDDs will get executed. Otherwise, that RDDs will not have any effect at all. Right? What happened? Is it not even starting? Did you upload the new one? No. I gave you the new file now. Did you import it?
Yes, this is the new one.
Did you import it?
Yeah, I got this file, but this is the one that I got it from you.
Where is the virtual machine?
I didn't get that. This is the file that I got it from you. You sent it.
Can you go back to this dashboard? Where is your virtual box? The basic.
I think it is gone. The update.
Huh?
The update, I think it is gone.
Install virtual box, Krishna.
From the
From in the virtual box only you have to import the appliance, correct?
yeah, from VirtualBox, if I want to install, I took it from you from pen drive.
That is not virtual box. That is Cloudera virtual machine.
So VirtualBox on. I deleted that one.
Look at this. You need this one. I am talking about this one. This one.
Yeah, that one I need
That
to install.
that is the container for any virtual machine. I gave you virtual machine.
I removed that one.
Please leave a photo, huh? After this much. See?
6.0.
Ah. 6.0 is the latest. I leave it to your risk if you are
You
using
got
the
an error,
latest.
Ravi, but
What? Error means type wrong. While scale line is equal to lines dot filter. Is there a text file there? Do you have a text file?
did me
Ah, you should have a file which
Right.
is available.
path. Okay, yeah.
That's why you are getting the error.
So this path to readme. So it's
Mahesh,
local.
create any file called
Right.
twinkle.txt and give the path of that.
Okay.
Are you starting Spark, Shashi? No? No way.
No, I'll get a new machine. Otherwise, I'll fix it.
First learn Spark, Scala. Come for one more batch when I take Spark.
Why I don't have L1 tab in my computer? I have L2, L3.
That is very, very old, Krishna.
Means L1.
Only latest computers are having it. L2 and L3 it is there, right? That is more than enough. Happy.
Yeah, I'm just curious.
More, it might be the processors after that which has got the L1. Srini started reading the book. I got the message. Everything is there. That Presto, all the topics are there in that book. That's a very comprehensive one. Whatever I covered, most of the things are there inside. What happened, Mahesh?
Working on it.
Anytime when anything is happening to your system, do not delete VirtualBox. Delete the virtual machine within the VirtualBox. VirtualBox will remain as a container. It is like computer.
I think I uninstalled all the applications. I think on a mission to create space. I don't
Exactly.
I don't know.
Not a capital. This is small.
Scala lines illegal characters.
Where is it?
Now it's
See the way in which the double quote is copied. This double quote should be there in the Scala beginning also.
This double quote in the text file.
See that?
Not in the text file. I'm telling you to put it like this.
So you
Right.
mark, no, that it's least. Every time when you